Okay, so now we're going to talk about evaluating the integral and the idea of finding the area under the curve more accurately. So earlier I said this, I'm going to repeat it. But basically, if I'm trying to find the area under the curve, from A to B, in order to get more and more accurate, I need these rectangles to be skinnier and skinnier. So skinny, in fact, that the width of the rectangle would almost be getting close to 0. And if my rectangles were almost getting to a width of 0, you would have basically an infinite number of rectangles. So you'll see down here that one way that we can solve finding the area of the region under the graph is to do a limit where n, the number of rectangles, is going towards infinity. So they're writing this now with sigma notation, and basically this is showing that you're going to find the sum of each, this is the endpoint, the y value, times the change in x. So you're finding the sum of all the rectangles. Change in x, you can find it by doing b minus a, dividing by how many rectangles there are, which in this case is going to infinity. And x sub I is equal to a plus I delta x, which is the same idea that I discussed in the video before. This is considered the right Riemann sum, and it does say that the expression can be changed to use left endpoints or midpoints, but we're just going to use this one here. Okay. These down here, we're going to use them in just a minute. So these are just some common things that are repeated or seen in many of these questions. So it's almost like you would want to know these to be able to apply it. Okay.